All right, strap in everyone, because today we're diving headfirst into the wacky world of quantum mechanics.
Buckle up. It's going to be a wild ride.
You guys sent in some awesome stuff for this deep dive. Like, we've got everything from the bare bones basics all the way to some seriously mind-blowing implications, you know?
Yeah.
We even have this super cool piece called How Strange is the Quantum World.
Ooh, I love that one.
I know, right? It's got tons of vivid analogies and explanations.
Yeah, it's really engaging.
I think we're in for a real treat with this one.
It's going to be fun.
So I think a lot of people are going to be surprised by just how much quantum mechanics actually affects our daily lives.
It really does, and in ways you wouldn't expect.
Yeah, exactly. And not just like, in the obvious ways.
Exactly.
Let's start with some basics. The article compares quantum particles to Legos, the building blocks of reality.
Oh.
It's a really cool analogy, but how does that actually work?
Well, you can think of it like this. Just like Legos can be combined in like a zillion different ways to build all sorts of complex structures.
Right.
Quantum particles interact to form everything we see and experience around us.
Okay.
And these interactions are governed by what physicists call the four fundamental forces of nature.
Okay, I'm with you.
You've probably heard of gravity.
Of course, yeah.
But there's also the strong nuclear force, the weak nuclear force, and the electromagnetic force.
Wow, those all sound pretty intense.
They are.
So, like, gravity is the force that keeps me from floating away.
Exactly.
But what about these other ones?
Well, the strong nuclear force is kind of like the super glue of the universe.
Okay.
It holds the nucleus of an atom together.
Wow.
The weak nuclear force is responsible for radioactive decay.
Oh, okay.
And the electromagnetic force, well, that's everything from magnets to light itself.
So these forces are like working behind the scenes at these tiny levels to create everything we see and experience.
Pretty much, yeah.
But wait, I remember learning in like high school physics that gravity is supposed to be the weakest force.
Right.
But if that's true, why is it so dominant in our everyday life?
Yeah, that's a great question. That's actually one of the biggest unsolved mysteries in physics today.
Really?
Yeah. It's called the hierarchy problem.
Okay.
Why is gravity so much weaker than the other forces?
It's weird to think about, right?
Yeah. You'd think the force that shapes entire galaxies would be, like, the strongest one.
You'd think so.
But at the quantum level, it's barely even there compared to the others. Scientists are still trying to crack that one.
Huh. So even the basics of quantum mechanics lead to some pretty deep questions.
Absolutely.
Okay, the article also mentions some seriously weird concepts like superposition.
Ah, yes.
It uses this analogy of a ghost passing through a wall. So are you saying that things can actually be in two places at once?
Yeah, that's exactly what superposition suggests.
Whoa.
And it's not just about location either. Think of an electron spinning. It can be spinning both clockwise and counterclockwise.
At the same time.
At the same time, until we actually measure it.
That's crazy.
Yeah. So it's not just that we don't know the state of something until we look.
Right.
It's that it exists in multiple states simultaneously.
Okay, that completely boggles my mind. I kind of get the analogy, but can we actually see this happening, Or is it just theoretical?
Oh, no, it's not just theoretical. Superposition has actually been demonstrated in laboratories with actual particles. And it's the foundation for technologies like quantum computers.
Hold on, quantum computers. I feel like we're jumping ahead a bit, aren't we?
We can circle back, but it's a great example of how these seemingly bizarre concepts have real-world implications.
Okay, yeah.
Imagine a computer that can be both on and off at the same time. That's the power we're talking about.
Okay, now I really need to hear more about this. The article compares a normal computer to an abacus.
Right.
And a quantum computer to a magic calculator.
Yeah. It's not magic, but it's pretty close.
I mean, can they really do things that regular computers can't?
Think of it this way. A regular computer solves problems step by step.
Okay.
Like moving beads on an abacus.
Right.
But a quantum computer uses the principle of superposition to explore many possibilities simultaneously. It's like throwing a handful of dice all at once and seeing all the possible outcomes instantly.
Wow.
So this allows them to tackle problems that would take classical computers millions of years.
What kind of problems?
Like simulating complex molecules for drug discovery.
Okay.
Or cracking modern encryption codes.
That sounds incredibly powerful, but also kind of scary. Could quantum computers get so advanced that they like, threaten our privacy?
That's a valid concern.
Yeah.
We have to be very careful and think about the implications of this technology as it continues to develop.
Right.
But it's important to remember that quantum computers aren't going to replace your laptop or your smartphone.
Yep.
They're more like specialized tools for very specific jobs.
So they won't be helping me with my taxes anytime soon.
Not unless your taxes involve simulating molecular interactions. They're amazing machines,
Yeah.
but still very much in their early stages.
Good to know. The article also mentions quantum tunneling, which sounds like it's straight out of a sci-fi movie.
Oh.
Is that even a real thing?
Oh, it's absolutely real.
Whoa.
Quantum tunneling is this crazy idea that a particle can pass through a barrier,
Okay.
even if it doesn't have enough energy to do so. Imagine a ball rolling up a hill.
Okay.
If it doesn't have enough energy to reach the top, it'll roll back down, right?
Right.
But in the quantum world, there's a chance it could tunnel right through the hill.
Okay, now that sounds like magic. But wait, if particles can just tunnel through anything, wouldn't everything just be, like, falling apart?
Well, it's not quite that simple.
Okay.
The probability of tunneling depends on the thickness and height of the barrier. Like, a thin sheet of paper is much easier to poke a pencil through than a thick brick wall.
That makes sense.
Yeah.
So there's a chance my coffee cup could tunnel through the table.
Theoretically, yes, but the probability is so incredibly tiny
Okay.
that you'd probably have to wait longer than the age of the universe to actually see it happen.
Okay, phew, that's a relief.
For big, everyday objects like coffee cups, these quantum effects are mostly averaged out.
So quantum tunneling is real, but it's mainly happening at these super tiny levels.
Exactly, and it's actually the basis for some very real technologies,
Like what?
like the transistors in your smartphone.
Whoa, that's so cool. Okay, so we've got these quantum particles behaving in these super strange ways,
Right.
interacting through these fundamental forces. But then the article takes things to a whole other level with this concept of quantum entanglement.
Oh, entanglement, now we're talking.
They use this analogy of two gloves, one in New York and one in Los Angeles.
Right. Isn't that a great visual?
Yeah, it really helps.
It really does.
But what is it actually about?
Quantum entanglement is one of the most mind-blowing concepts in all of quantum mechanics.
Okay.
You've got two particles that are entangled,
Hmm.
and no matter how far apart they are, they're intrinsically linked. Like, if you find out one glove is right-handed, you instantly know the other one is left-handed, even if they're light years apart.
Wait, so is that like communicating faster than the speed of light?
That's the question that has puzzled physicists for decades.
Yeah,
You see, Einstein called it spooky action at a distance.
it does sound kind of spooky.
Right. The problem is that even though we can measure the correlation between entangled particles,
Right.
we can't actually control what state we observe. It's like you have two coins that always land on opposite sides,
Okay,
but you can't choose which side will be heads or tails.
gotcha. So it's a connection, but not like a way to send messages.
Right. At least not that we know of.
That makes sense. But it's still super weird to think about.
It really is. That's quantum mechanics for you.
This is already so much to take in, and we're just getting started.
Oh, yeah. We've only scratched the surface.
I can't wait to see what other mind-bending concepts we uncover as we go deeper into this strange quantum world.
Me too. There's so much more to explore. From the duality of light to the mysteries of the very early universe.
It's going to be a wild ride.
Definitely buckle up.
So we've established that quantum mechanics is seriously strange, right?
Definitely strange.
We've got particles behaving like waves and tunneling through walls and even sharing like spooky connections over huge distances.
It's wild.
But what does it all actually mean?
That, my friend, is the million-dollar question. And it's one that has caused some pretty heated debates.
Oh, really?
Oh, yeah, among physicists. You see, there isn't just one way to interpret what quantum mechanics is telling us about reality.
Wait, so there are different interpretations of quantum mechanics?
Yep.
I always thought it was like, a set of rules about how the universe works.
There are definitely rules, but there's a lot of room for debate about what they actually mean.
Okay.
Like, take the Copenhagen interpretation, for instance. That's like the most common one.
Right.
It basically says that when we observe a quantum system, we force it to choose a definite state.
So it's like we're influencing reality just by looking at it.
That's kind of trippy.
Yeah, that's a wild idea.
It is, but there are other interpretations too.
Oh, like what?
Like the many worlds interpretation, which takes a very different approach.
Okay.
It suggests that every time a measurement is made in the quantum world, the universe splits.
Splits.
Yeah, into multiple branches, with each representing a different outcome.
So you're saying there are countless parallel universes out there, each with a different version of me.
It's definitely a mind-bending concept.
It really is. So we don't actually know which interpretation is the right one.
Nope. We don't know which one, if any, is actually correct.
So even the experts are still debating what's really going on.
That's right. Which is kind of exciting, right?
Yeah, I guess, in a way.
It means there's still so much we don't know, so many mysteries left to solve.
It's a little unsettling, but yeah, also really cool.
Right.
Okay, well, let's dive into one of those mysteries. The article mentions something called quantum field theory. What is that all about?
Oh, quantum field theory is like the love child of quantum mechanics and special relativity.
Okay.
It's basically a framework for understanding how particles create the forces we experience. It's really the bedrock of particle physics.
So like a deeper level of quantum mechanics, combining it with Einstein's ideas about space and time.
That's a great way to put it.
Wow.
It's a pretty complex theory.
Yeah, I bet.
But it's been super successful at explaining the behavior of these fundamental particles and even predicting new ones.
Well, that sounds like a whole other deep dive for another day.
Maybe we'll tackle that one next time.
Yeah, we should. I do have one more question about something we talked about earlier, though. Entanglement. If these particles are truly connected, even across huge distances, does that mean we could use them for, like, faster-than-light communication?
Yeah, that's the question that has stumped physicists for, well, basically forever.
Well, it seems like you should be able to, right?
You'd think so, but the thing is, even though we can measure that correlation between entangled particles,
Right.
we can't actually control what state we measure.
What do you mean?
It's like having those two coins that always land on opposite sides, but you can't choose which one will be heads and which will be tails.
Oh, okay.
So, as far as we know at least, entanglement can't be used to actually send information faster than light.
So it's a connection, but not like a usable communication channel.
That's the idea, yeah.
I mean, it's still pretty mind-blowing.
Oh, absolutely. But hey, that's quantum mechanics for you. Always full of surprises.
All right, let's shift gears a bit and
Yeah.
talk about what all this means for the universe as a whole.
Okay, I like where this is going.
You know, the article mentions something called quantum cosmology. It sounds like it's from Star Trek or something.
It does, doesn't it? Not quite warp drive,
Right.
but pretty amazing. Quantum cosmology basically uses quantum mechanics to try and understand the very early universe just after the Big Bang.
Whoa.
It deals with questions like, where did the universe come from? What were things like in the first, fraction of a second?
So we're taking the rules of the very small and applying them to the very large.
Exactly.
That's so cool.
It has led to some pretty incredible insights.
Like what?
Like the theory of cosmic inflation, for example.
Okay.
Which tries to explain how the universe expanded so rapidly in those first moments after the Big Bang.
I've heard of that. Okay, and speaking of incredible insights, the article also mentions the idea of the multiverse.
The multiverse.
Are you telling me there could be other universes out there?
It's a possibility, and one that many physicists actually take very seriously.
Really?
Yeah, there are a few theories that suggest the existence of a multiverse, like the many worlds interpretation we talked about earlier. Right.
Or the idea that our universe is just one bubble in a vast sea of other universes.
Okay, now my head is really spinning.
It's wild. Right.
So you're saying there could be countless other universes with totally different laws of physics.
It's a mind-blowing concept.
Yeah.
And, I mean, we don't have any definite proof yet.
Right.
But some physicists think that there might be clues, evidence for the multiverse.
Okay.
Hiding in the cosmic microwave background radiation.
So like the afterglow of the Big Bang.
Exactly. It's like searching for fingerprints of other universes on the oldest light in the cosmos.
That is incredible.
It's a long shot for sure.
Yeah.
But it really shows how far quantum mechanics has pushed our understanding. I mean, we're asking questions about reality that would have been pure science fiction just a few decades ago.
It's a lot to wrap your head around. Okay, so we've gone from the tiniest particles to, the entire multiverse.
Quite a journey.
But I want to bring it back down to Earth for a minute and talk about the implications for us humans,
Because, with great power comes great responsibility, right?
Absolutely. And as quantum technology keeps advancing, we have to be really careful about how we use it.
Yeah, I mean, it could be used for good or bad.
Exactly. We need to make sure we're using this knowledge wisely.
I was reading about quantum computers and how they could potentially be used to break encryption.
Mm-hmm.
The stuff that protects our online data.
Right.
It's kind of scary.
Right. It's definitely a legitimate concern. Quantum computers could be a serious threat to cybersecurity.
Yeah.
It's something we need to start addressing now before it's too late.
So it's a race against time then.
In a way, yeah.
Yeah.
We need to develop quantum-resistant encryption
Uh-huh.
before those with bad intentions get their hands on powerful quantum computers.
That makes sense. And I guess it's not just cybersecurity we have to worry about, right?
Yeah, no, it's much broader than that. This tech could be used for surveillance, manipulating information, you name it,
Right.
even developing new weapons.
It's kind of a stark reminder that scientific advancements don't happen in a vacuum, you know?
That's true.
We need to think about the ethical and societal implications from the very beginning.
I completely agree. We need to have open discussions about these things. Not just between scientists, but policymakers, ethicists, everyone, really.
Yeah, I think we've covered a ton of ground already in this deep dive. From the basics of quantum mechanics to, like, questioning the nature of reality, even the possibility of multiple universes. It's wild.
It's been quite a journey, and there's still so much more to discover.
Yeah, that's the thing, right? As much as we've learned, it feels like we're just scratching the surface of this quantum world.
Exactly. There's always more to learn.
So as we wrap up this part of our deep dive, what are your final thoughts for our listeners?
Well, I think the most important thing is to remember that quantum mechanics isn't just some abstract theory.
Right.
It's woven into the fabric of reality, and it's already changing the world in profound ways. I mean, we're at the very beginning of a quantum revolution. The possibilities are truly mind-boggling.
It's an incredible time to be alive, for sure.
Absolutely.
You know, it's pretty amazing to think that something as, like, abstract as quantum mechanics is actually having a real impact on our lives right now.
It really is.
I mean, we've talked about things like quantum computers and cryptography, but what other practical applications are there?
Oh, the potential applications are huge.
Yeah.
Quantum sensors, for example,
Right.
are already being used in all sorts of fields.
Like what?
Like medical imaging, navigation systems, even financial modeling. They offer this incredible level of sensitivity and precision.
So we're talking about technology that can detect things we could never even see before.
Exactly.
What kind of impact could that have on something like medicine, for instance?
Imagine being able to detect cancer cells at the very earliest stages.
Wow.
Or monitor brain activity in incredible detail.
That would be revolutionary.
It would. Quantum sensors could totally revolutionize diagnostics and treatment, leading to much more personalized and effective healthcare.
That's incredible. But we've also talked about the potential downsides of this technology, right?
Right.
So are there any specific concerns when it comes to these quantum sensors?
Well, one concern is definitely the potential for misuse, like for surveillance.
Right.
Imagine sensors that could detect your heartbeat or even read your thoughts from a distance.
It's a little creepy.
Yeah, it raises some serious ethical questions about privacy and civil liberties.
It's like something straight out of a sci-fi movie, but not the good kind.
Exactly.
We really need to be careful about how we develop and use this technology.
Absolutely. We need open discussions about this stuff and really careful consideration of the ethical implications.
It's not just about what we can do, but what we should do.
Right, exactly.
Okay, so we've got these amazing technological advancements happening, but we also have these ethical concerns to think about. It feels like we're at a bit of a crossroads, you know?
I think that's a great way to put it. Quantum mechanics is really challenging us to rethink how we understand the universe and our place within it. It forces us to confront questions about the nature of reality, consciousness, even free will.
It's a lot to grapple with.
It is. But I think it's important that we embrace these questions, even if the answers are a bit uncomfortable.
Yeah, I agree. It pushes us to think outside our comfort zone.
Exactly. And in doing so, it opens up incredible new possibilities.
So where do we go from here? What are the next big steps in this whole quantum exploration thing?
Well, scientifically speaking, there's still so much we don't know.
Yeah.
I mean, we need to keep developing our theories, keep pushing the boundaries of experimentation, and keep exploring the potential of this technology.
Okay, and what about ethically?
We need open and honest conversations about the implications of all this.
Yeah.
Involving scientists, engineers, policymakers, philosophers, the public, everyone, really.
It's really about shaping the future, isn't it?
It is. It's about making sure this tech serves humanity, not the other way around.
Well, I think it's safe to say we've covered a ton of ground in this deep dive.
We have. It's been a wild ride.
From the tiniest particles to the vastness of the cosmos.
Right.
And we even touched on some pretty profound philosophical and ethical questions.
It's all connected.
It really is. I hope our listeners are walking away with a sense of wonder and curiosity about the quantum world.
Me too.
It's a world full of mysteries and possibilities, and it's up to all of us to explore it responsibly and make sure we're shaping its impact on our future.
Couldn't have said it better myself.
Well, on that note, I think it's time to wrap up this episode of The Deep Dive.
Sounds good.
Until next time, everyone, keep those quantum questions coming.
And never stop exploring.